So it's not very impressive, but it's our standard. Now, how do we calibrate it?
Yeah.
Well, you got to calibrate it by using a known temperature. Well, one of the known temperatures is the triple point of water,
Triple point of water.
which is defined to be 0.01 degrees C.
Okay.
So we use this thing called a triple point of water cell, where all three phases of water, solid ice, water vapor, and liquid water exist in equilibrium at the same time. And that's defined as the triple point of water. So it's in this glass cell. And I'm going to try to take that out and show it to you. Hopefully it's still... So you have to freeze this thing, and then you have to age it. And if you did everything right, you have ice, water, and water vapor coexisting at the same time. And you can use that to calibrate your thermometer.
Wow.
Yes.
Oh, and that's the ice.
So you see the ice, and the water is here.
Inside.
And then the water vapor is above the water. So right now, since I've got all three phases in equilibrium, ice, water, and water vapor. So at the very bottom, you can see the bottom of this tube is where that yellow sponge is. That is going to be where my calibration point is, and that is defined at the triple point of water to be 0.01 degrees C.
And that's where this have to touch the yellow?
Yes.
Okay.
Yes. So the idea is this stays in this bath, which is made up of 90% water and 10% alcohol, ethyl alcohol. So you can get very low temperatures here. So it maintains this at the proper temperature, and this goes down inside.
Inside the container? Okay.
Yeah, through here. So this goes back on top, and then
and goes through
then
there.
it goes through here and goes down inside. And so over here, this is the electrical resistance in ohms. So it's going to change here, and it will eventually settle down at something like 29 or 25.417. And when it stops changing, that's the resistance of this probe at the triple point of water. So when you measure a temperature, that's your calibration point. Now you can also do other calibration points by taking the bath, this bath, and setting it to different temperatures and dumping
doing
it
the
in
same
and,
thing.
and doing the same thing, measuring the resistance as a function of temperature. When you go to use the probe, what you're really measuring is resistance. So after you've calibrated it, you've got a chart of resistance versus temperature.
Oh my goodness, and look at all these wires. So this probe is connected to this?
Yes, which is connected to this.
Oh wow.
This is a multiplexer, so that you can put in up to 10 different probes into this instrument, and you can select them by just pressing these buttons. So it's a very versatile instrument. So that's one of the things that I do here is I calibrate thermometers for our use in the group.
Nice. And how often do you have to calibrate them?
About every 2 years or so.
Oh, okay. That's not bad. I'm like every month. That's a lot of probes.
No. But,
okay. So every 2 years.
But we need repeatability of thermometers to about 20 milli-C, so 0.02 C. That's good enough for what we do here.
Okay.
If I needed, better accuracy than that, then I'd probably have to calibrate more often, because these things do drift a little bit with use, and if you bang them a little bit, they'll change. But